Okay, so here we are. Today we're going to look at some applications of trig. How to pick out the right triangles and stuff that we need. Now in this figure, I'm going to give you one right angle right here. So we know that that's a right angle. Up here, I'm going to say this is a 76-degree angle. I'm going to give you this dimension here as 300 feet. Across here, I'm going to give you this dimension as 420 feet. What I want you to find, let's see, is there anything else I need there? Oh, I'm going to give you the height here as 255 feet. What I want to find is what this angle right here is. Now, when we have right angles given, it helps. We can usually find right triangles off of them, but sometimes not. One strategy we use if we have a right angle is to make sides that are parallel to the sides of that angle. So here we have this right angle here. So I need to make a side parallel to this one, or both. But it can't just be parallel, it has to be through another point. So the only other significant points we have are this, this, and this. Well, drawing a parallel line through this one doesn't do anything. So having a line parallel up here does no good, and having a line parallel over here would do no good. So we're going to look at this point here. If I draw a line parallel in this direction, that gives me a right angle here, and another one in this direction gives me a right angle here. Of course, that would be a right angle there as well. What we have here is a rectangle. And what it does is it gives us two right triangles, here and over here. If I could find, and the nice thing about rectangles is they translate dimensions. If I were to know the dimensions of this side right here, which I do, is 255, that tells me the dimension of this side over here is also 255. If I were to know the dimension of the top, I would know the dimension of the bottom, which I don't know yet, but I will soon be able to find. So that's 255 feet there. We can find this dimension here by simply subtracting from 300. 300 minus 255 is 45 feet. Now that we have that that's 45 feet, we have a right triangle where we have a second angle and one of the sides, so we can find the other dimensions. In this case, the dimension we're most interested in is this one right across here. So let's redraw that triangle. There's a right angle. This is 76 degrees, and this is 45 feet. Let's find this side here. So according to our 76-degree angle, the 45 is the adjacent leg, and the side we're looking for down here is the opposite leg. So that would be tangent. Tangent of an angle equals opposite over adjacent. Do we know the angle? So yes, 76 degrees. Do we know the opposite side? No, that's what we're looking for here at this point. The adjacent side is 45. So we're going to put a tangent over 1 to make it a proportion. So this is going to be tangent of 76 degrees times 45 divided by 1, or just tangent of 76 degrees times 45. Come on, let's go on here. Which gives us 180.49. So if that's 180.49 feet, that makes this 180.49 feet, which makes this 180.49 feet, which makes this 230. Hey, not drawn to scale. 239.51 feet. If I drew it to scale, it'd be too easy for you. So now we have this triangle here where we know two of the sides, and we know we have a right angle, so we want to find that second angle. So let's draw that. This side is 255. This side here, we just said 239.51. And we're looking for this angle here. So what we have according to that angle, if I call that angle A, we have the opposite and adjacent again, which means we're still using tangent. This time, though, we don't know the angle. Angle is what we're looking for there, so we'll just put the A in for the angle. Opposite's 255, adjacent's 239.51. Now we're looking for the angle instead of one of the sides. So how do we do this differently? We do an inverse tangent. So inverse tangent at 255 divided by 239.51. So second tangent, 255 divided by 239.51. 46.79 degrees. That is the angle we were looking for right here. So we're all done. See how easy that was? Okay, so let's see what we have here. I want to find this dimension right here. How high the top of that round piece is out of the V-block. So in this first one, the strategy we used was to find parallels to a right angle and use basically vertical and horizontal dimensions to create right triangles. Here we're going to use a different strategy. We're going to use tangents to a circle. Whenever there's a circle with a tangent to it, you guys remember what a tangent is, right? It just touches the edge of the circle without actually penetrating it, going into the circle. If we draw a radius of the circle to that point of tangency, it forms a right angle. That is another great way to form a right triangle, is by drawing a radius to a tangent. Now, well, not yet. In this case, we also know when you have a circle, if you have two tangents to a circle, if you go from the center of the circle to where the two tangents cross, you cut the angle in half. So this is going to be 30 degrees here instead of 60. This, we know, is a radius, so it's going to be half of the diameter, so it's going to be 2 inches. So now we can find this distance from here to here. Because what we have is we have a right triangle that's 30 degrees and 2 inches. And we're looking for, I'm going to call this here y. I'm looking for that dimension. Y would be the hypotenuse, and with the 30-degree angle, 2 is the opposite. What trig function? Sine of an angle equals opposite over hypotenuse. So I'm going to plug in. I know my angle is 30 degrees, so sine of 30. Opposite is 2 inches. Hypotenuse is what I'm looking for here. I called that y. So I'll make this, bless you, I'll make this a proportion. I'll cross multiply and divide. 1 times 2 divided by the sine of 30 is 4, correct? So this is 4 inches. So now here's what I have. I have 4 inches to the center of the ball. What's this distance from here to here? 2. It's just a radius. So I've got 2, 4, and 2, which adds up to a total of 8. 2 and 4 is 6, plus another 2 is 8. 5 minus 8 makes 3. 5 is the distance from here to here, right? So 8 minus 5 makes 3. That's how far that must stick up above. How do you do the 8? Take the 2 plus the 4 plus another 2.
So sine of 30
Sine of 30 is 0.5. Equals the opposite of hypotenuse. So the opposite side is 2. The hypotenuse is what we're looking for. So it's 1 times 2 is 2 divided by the sine of 30 gave us 4. Because sine of 30 is 0.5, right? What do you think? Perfect. Well, you guys are going to try some. On page 760, I thought it 35-3. Look at 1 through 15, do the odds.